All right, here we go, guys. This is the second part of the review for our final. This was Chapter 9, where we did our quadratic functions. So the first part here is identifying all these key characteristics when we're given a graph. So the first thing we have to remember is that this is a parabola. This is the graph of a quadratic function, which means it has a vertex, an axis of symmetry, all of this stuff over here. So the first thing I notice is that this parabola opens up, which means my vertex, which is right here, is all the way at the bottom. Since my vertex is at the bottom, that means I have a minimum value for this parabola. And the minimum value is always going to be a y value, and it's either the highest or the lowest y value that the function takes on. So in this case, the lowest that this function goes is -4. This is always the y value of the vertex. So let's actually talk about what the vertex is. We need to remember the vertex is always a coordinate point, x, y. This point right here, I went 1 to the left and down 4. That means this is the point -1, -4. The axis of symmetry is a vertical line that goes through our parabola. So it is right here. We're just going to draw it in right away. That's our axis of symmetry. And since it's a vertical line and it's got an x in it, we know that the axis of symmetry is going to be x equals. So in this case, it goes through -1, so it's x equals -1. The y-intercept is where the parabola hits the y-axis. And it's always when x equals 0. So in other words, we don't move left or right. So here's my y-axis, and it hits the y-axis right there. This is my y-intercept then. So I know it's the point 0 something. In this case, it happens to be -3. And then we need our solutions. The solutions to a quadratic are the x-intercepts. So they're where y equals 0. It's where the parabola crosses the x-axis. So remember, we said sometimes it has two solutions, sometimes it has one solution, and sometimes it has no solutions. In this particular case, this parabola has two solutions, and they are right here. So that's the point -30 and the point 10. Okay. Now, the other part of this was being able to create your own graph. So we give you an equation, and the first thing you need to do is put it in standard form. So you have to remind yourself that standard form is y equals ax squared plus bx plus c. So when we look at this equation right here, we notice it's already in standard form, which is really good for us. -2x squared minus 4x plus 6. So we need to identify a, b, and c, because we're going to need that in order to move on. So our a value is -2. It's the leading coefficient. Our b value is -4, and our c value is 6. It's really, really important to make sure that you're in standard form and that you then identify those values correctly. To decide whether the parabola opens up or down, we need to look at the leading coefficient. The leading coefficient is always the a value. So in this case, our a value is -2. If our a value is negative, that tells us that the parabola opens down, which means it's going to look like this. So the vertex of our parabola is all the way at the top, which means we have a maximum value for this particular parabola. Next, we need to find the vertex. To find the vertex, we need our formula, x equals -b over 2a. So in order to do that, we're going to need negative parentheses over 2 parentheses, and we're going to fill in our a and our b value. So our b value is -4, and our a value is -2. So we get a +4 over a -4, which equals a -1. That means then that our vertex has an x value of -1. It also means that our axis of symmetry is x equals -1. The next part here is to take our x value that we found and substitute it in so that we can find the y value of our vertex. So I always start by rewriting my original equation. So y equals -2x squared minus 4x plus 6. Now I'm going to take out the x values and I'm going to substitute in the y values. I'm going to substitute in the x value that I found. So the x value that I found was -1. So you can see, here's my original equation, and all I did was take out x and substitute in the x value that I found. So if I put that in my calculator, let's see, I'd get -2 plus 4, which is 2 plus 6, which is 8. So we get a y value of 8. So that means our vertex is the point -1, 8. It also means that our maximum value is 8. Because remember, our min or max value is always the y value of the vertex. The axis of symmetry is always the x value of the vertex. With me so far? Hopefully. Okay, so now let's do the y-intercept. So we said that the y-intercept is when the parabola hits the y-axis. It's always when x equals 0. So we know for sure that our x-intercept is going to have 0 something. Well, hopefully you remember that that's the c value when we're in standard form. So in this case, the y-intercept is the point 0, 6. Okay, now comes the very, very important part. So we need to take our vertex, which is the point -1/8, and put it in the middle of our table of values. We can't graph this parabola without having some more points. So we put our vertex in the middle. Okay? Then we need to add 1 to our x value. So we're going to get a 0. Add another 1 to our x value, and we're going to get a 1. Then we're going to go back to our vertex, and we're going to subtract 1, and we get -2. Subtract another 1, and we get -3. So now you should have 5 x values that all go in a row. -3, -2, -1, 0, 1. Now all we have to do is go to our calculator and use our table to help us actually create the table. Use our calculator, excuse me. So go to y equals, and hopefully everything is cleared out. If it's not, press clear. -2x squared minus 4x plus 6. Now remember, we need to hit second and then graph to get to our table. So second, graph. And if we scroll through here, we can see here are some x and y values. So we need to pick the ones that we wanted. So let's see, here we go. -3 in our calculator gives us 0. -2, we have a 6. -1 is 8, which is good. It means we found our vertex correctly. If we plug in 0, we get 6. And if we plug in 1, we get 0. So remember, this is where we have, because of that axis of symmetry, these values should match over. Okay? Now we're going to plot our points. So -1, +8 is right here. And I'm going to also draw my axis of symmetry. Remember, that's the dotted line. And then I'm going to plot the point 0, 6. And I'm going to reflect it over the x-axis. I'm going to plot the point 1, 0, and I'm going to reflect it over. So since I'm 2 spots away from my axis of symmetry, I'm going to go 2 spots on the other side, which means my graph looks like this. And if we look, we originally said that our parabola should open down, which is correct, and it goes through these points. Our maximum value is 8. That's the highest it goes. Now we've got our solutions. We know that that's where it hits the x-axis. So that's going to be negative 3, 0, and 1, 0. Okay. So we know to find the vertex, we need x equals negative b over 2a. Hopefully you remember the quadratic formula. That's our negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you're singing it. Okay? And the min or max is always the y value of the vertex. So we get that by substituting the x value that we get when we do negative b over 2a. Okay, really quickly, I'm going to do a quadratic formula example. So in order to use quadratic formula, it has to be in standard form. And right now, these are not on the same side. So I'm going to subtract 2x squared from both sides so that I get 0 equals negative 2x squared plus x plus 7. And now from here, I need to identify my a, my b, and my c. So a is negative 2, b is 1, and c is 7. Now we're just going to use the quadratic formula. So I always start by writing the formula first. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. You'll notice the second time I wrote it, I didn't write those letters, I just put parentheses. So now I'm going to go through and fill those in. So negative, my b value is 1. B squared, so 1 squared, minus 4a, which is negative 2, c, which is 7, all over 2a, which is negative 2. Now we need to do the simplifying part. So we have x equals negative parentheses 1 really just means negative 1, plus or minus the square root of some number. I'm going to figure that out in a second. And I know on the bottom, 2 times negative 2 is negative 4. So I'm going to go ahead and use my calculator to figure out what this part is. So plug it in without the square root, remember. So 1 squared minus 4 times negative 2 times 7. And we get 57. Now we're going to do the square root of 57 in our calculators. And we get 7.55. So this is negative 1 plus or minus 7.55 all over negative 4. We have to remember that the plus or minus means we need two solutions. So it's negative 1 plus 7.55 over negative 4, and it's negative 1 minus 7.55 all over negative 4. So we're going to go ahead and figure those out. So alpha y equals, to get our fraction, negative 1 plus 7.55 all over negative 4. So we get negative 1.64 as one of our answers. And then if I do the same thing but change this to a minus sign, we get 2.14 as our other solution. All right, so that's all about graphing quadratics and solving quadratics by graphing, and then the quadratic formula. So again, in your packet, you've got some multiple choice examples. I will upload the answers so that you guys can check your work and ask any questions that you have.